Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly challenge. First question, find the winning player in the coin game. So basically, let us first read this question, then we'll check out the constraints of this question and then finally the coding part for the same. But before going ahead with the coding part, we'll go ahead that what intuition is required to be created in this particular type of question and how we are required to solve this question. Then only we'll go ahead with the coding part. So here, let us first read this question. So here in this question, you are given two positive integers x and y, denoting the number of coins with value 75 and 10 respectively. So basically, two types of coin denomination is being given to us, 75 and 10, and both are denoted by x and y, means basically count of both of these denomination are denoted by x and y. Alice and Bob are playing a game, each turn starting with Alice, and the player must pick up coins with a total value 115. So, if the player is unable to do so, they lose the game. And return the name of the player who wins the game if both players play optimally. Here means optimally refers to the fact that first turn is of Alice, then Bob, then Alice, then Bob, like that. And at each turn, both of them basically pick up 115 total amount of the coins. Means basically whatever count is there, that is fine. But apart from that count, let me draw that. Like so basically here we are given with 75 and 10. These are the values of the coin. And if we take the first example, x equals to 2 and y equals to 7. That means that 72, here there are 2 coins of 72 and here are 7 coins of 10. That is the thing. So for that purpose, now first turn would be of Alice, where Alice will pick 75, right? And then after picking 175, then she'll check that this 10 which is there, right? So if we basically subtract from this, right, if we do subtraction, we will be getting something like 40, right? So this 40 which is there, so we need to check that this difference which is there, if we divide that by 10, right, so it is completely divisible, right? And we are required to have other coins which are of 10, right? So that means she will, and it will be like 4 coins, right? So she will subtract that from this, so now remaining will be 3 coins. So basically 7 minus 4, so she will be picking 1 multiplied by 75 plus 4 multiplied by this 10 which is there, right? So this is what she will be picking, means 1 and 4, totally 2 coins she will be totally 5 coins she will be picking. So that would be the thing. So now after this, what will happen, our x would be x minus 1, now it will be just 1. 7 minus 4, now it will be 3. Now these are the denomination which are left. Now comes the part for the Bob. So when Bobs come into picture, means next turn is of the Bob. So Bob will pick the 1 coin which is remaining, right? So Bob will pick 75, and when Bob subtracts that 75 from this 115, Bob gets the number as 40. Now Bob tries to whatever remaining is there. So now Bob will check that yeah, it is divisible, but whatever answer he is getting, that is 4. So basically 4 is greater than whatever remaining coins are there, right? So in this context, Bob will lose, right? So in this context, Bob loses and Alice wins. That is the scenario here. So basically here the thing is that we need to check one by one that how many combinations is possible at each player's turn. If at that particular point of time player is able to get 115 as the total value of the coins, then that player is good to go ahead. If the next turn which comes into picture of the other player, if that player is not able to get that 115 coin, the way here Bob was not able to do, right? So because of this fact, Bob loses and Alice wins. So that is the thing which we are required to do in this particular question and required to return as per that scenario only. Now here, this was the first example, fine. Now in the second example, if you see, in the second example, x equals to 4, y equals to 11 and answer is Bob, right? So here the thing would be, first turn would be of Alice. So anyhow, now x will become 3 and again Alice will pick 4 coins. Anyhow, total is 115 only, right? So now when Alice picks 4 coins, so when she picks 4 coins, so 11, if we subtract 4 from 11, it would be something 7, right? So now 7 would be left. So now Bob is also eligible to pick more out of that, right? So now the new basically the new x would be 2 because Bob picked out 1, and then remaining from this would be 3, right? So at this point Bob is also able to do, and here at this point Alice is also able to give her turn perfectly. Now next turn comes for the Alice. Now Alice will pick 1 coin, that is fine, so 1 is remaining. But here if you see, there are just 3 coins remaining for the 10, right? So because of these 3 coins, but we require 4 coins, because when we subtract this 75 from 115, we are there with 40, right? And each coin is of value 10, right? So when we divide them, so that means we require basically 4 coins, and here we can clearly see there are just 3 coins, right? So because of this fact, Alice will lose at this particular point and thus Bob wins. So basically the main context of this particular question is that we are required to check at each point what is the current count of the coins remaining, so that at a particular point, if there are sufficient amount of coins remaining which sum up to 115, means if we multiply the value with the count and add them, then basically it sums up to 115, then it's fine to go. If it is not, then we are going ahead with making that player as losing the game, and the one who had played before, that particular person will win. So this is the thing which we are required to implement this in this particular question. Now we will first implement this, and then after that I'll let you know about the time complexity and space complexity. So I have already implemented the same. I'll share that window. Here's the one. So here is the implementation part. What I have done here is basically I'm taking Alice turn as true at the starting, because anyhow first turn is of Alice, right? Now here I'm using one infinite loop in which I'll break out of that particular infinite loop at that point when we are able to get a move, right? So that would be the thing in which from this for loop we'll just break out, and from this outer infinite loop we will be able to break out at this particular point when we are not able to figure out any move is possible. So that is the thing. Anyhow, this is not an infinite loop, this will go up to that 115 thing. Now so here, as first turn is of Alice, so Alice turn equals to true. Now move possible or not, at the starting we are marking it as false, because there could be possibility that Alice herself is not able to take the turn because of insufficient number of coins, because you can see as per the constraint the coins are like minimum, it could be 1, fine, but what if this x and y both of these are 1 only, then at that point Alice would also not be able to take the turn, right? So that's why at the starting we are making the move possible as false. Now the next thing, so here at this point we are checking for the value 75, that for this denomination of coin how many coins are there, and taking that much coins that they are less than 115. That is what we are doing. So first, for I equals to 0, when we are not selecting any denomination of 75 coin, right, and we are checking that I is less than equals to x, that is the count of that 75. It is less than, means basically our I is basically less than the count of 75, and then 75 multiplied by I less than equals to 115, because anyhow the sum means count multiply by the denomination of that particular coin, it should be less than 115. That is our target in this question. And then the increment any of the for loop, the way it works. So here remaining would be 115 minus 75 into I, means number of coins we have taken from that 75 denomination, we need to subtract that from 115 so that we can get that how many remaining are there, and we need to fulfill them with the 10. That is the thing. So that is what we are doing in the next line. We are checking if that particular remaining is divisible by 10 or not. So that's why we are checking remaining modulo 10 equals to 0. If that is true, that means it is divisible by 10, and that remaining divided by 10 is less than equals to y. That means that there are that much number of coins possibly left so that we can use them. So if both of these conditions are true, then only we can make the present move. So that's why here anyhow we need to subtract so that we can know that yeah, these many coins are already used. So now the next thing is that now the next person who will be playing, so that particular person will be able to move, make the move accordingly. Now we'll mark the move possible true, and we will break out from this particular for loop because the move was possible. Now here we have chosen that if not move possible, means at that particular point that move was not possible, means we have used all the coins, because anyhow we are doing this thing. So at some point there would be possibility that yeah, we have used that that combination of coins, that yeah, move is not possible. So at that point only we'll check that if Alice turn is there, if Alice turn equals to true, so then we will return Bob, because the move was not possible by Alice. That's why we'll return Bob. Else we'll return the Alice herself, because that turn was not of the Alice, that was of the Bob. Here we are switching the turns, means when this for loop would be done, right, so it will come out and it will check the turns. If Alice was doing the turn, then now next turn would be of the Bob. So that is how here we are checking for all the possible combination which are there, so that we don't miss out with any of the combinations. That is the thing. But anyhow, this is a brute force solution, so that is one thing. And now if there comes the part for the time complexity and the space complexity. Anyhow, space complexity is order of 1 because we are not using any extra space, but the time complexity thing, if you check, it is going up to I always check that it is less than equals to x. So here this loop will at max go up to this, means because and condition is there, so x should be also validated, right? So it will be minimum of x and that 115, right? So this internal for loop which is there, that would be, means its time complexity would be minimum of okay, fine, I did that wrong. Its time complexity would be order of minimum of 75 comma 115, not 75, x comma 115 you can say. So to be precise, it would be, because anyhow x could go up to 100 only, not more than that, right? So here the time complexity of this internal loop which is there, that would be up to 100 only, and overall we can clearly say that it would be of order of 1 only. That is the thing. And now for this outer while loop which is there, so this outer while loop breaks only at the point when move is not possible. At that point it will just simply get out, right? And this move not possible is basically dependent on this for loop only. That is also one part. And this for loop has the time complexity minimum of x. So the overall time complexity, if we say here, so it can at max go up to x into x, means x square. That we can say. Else, anyhow, means basically here the time complexity will be x into x, and space complexity is order of 1. So the time complexity here is x into x, and we know what is the x, and space complexity here is order of 1 because we are not using any extra space. So this was all for this particular question. If you have any doubt or if you have any suggestion, because here I have given you the brute force solution, I know there are much more optimized versions as well. So if you have any other optimized versions, you can comment that down. So this was all for this particular video. Thank you.